Okay, problem number 11. The first thing that we're asked here is to find the x-coordinates of all the absolute maximum and minimum points on the closed interval from -3 to +3. And the way we find an absolute max and min is we test the original function at the critical numbers and the endpoints. So we'll need to find f of -3. That's the left-hand endpoint. Then we have a critical number at x equals -1 because the derivative doesn't exist there. We have another critical number at x equals 1 because the derivative is 0 there. And finally we need to test at the right-hand endpoint, which is x equals 3. Now we're told in the beginning that f of -3 is 4, and at the end that f of 3 is 1. Now there's nowhere else in here that gives us any information on what might be the value of the original function at x equals -1 or x equals 1. However, we do know that the function starts at y equals 4 and goes up or increases from that point to x equals -1. Now it is important to note here that the function is continuous. So since the function is continuous, we definitely don't have a vertical asymptote at x equals -1. So we either have a vertical tangent or we have a sharp turn at x equals -1, and then we have a zero tangent, a horizontal tangent line, a derivative of 0 at x equals 1. So this function starts at x equals -3, y equals 4, goes up from there to x equals -1, comes down from there, has a horizontal tangent at x equals 1, continues to decrease, and ends up at y equals 1. That tells us that the absolute maximum has to occur at the relative maximum, which is at x equals -1, and the absolute minimum has to occur at x equals 3. The function starts out increasing and increases until it gets to x equals -1. From there it decreases, is stationary, and decreases again. So the highest point has to be when x is -1. Since the function continues to decrease after hitting that maximum point and ends up at y equals 1, which is lower than its original starting point, then that has to be the absolute minimum. Right, f of x increases until x equals -1 and then decreases from there, so the absolute max has to be at x equals -1. To justify the absolute minimum, we could say that f of x is only decreasing on the interval from x equals -1 to x equals 3. And since f of 3 is less than the original starting value, then f of 3 has to be the absolute minimum. Okay, so that takes care of part A. Part B, what are the coordinates, what are the x-coordinates of all points of inflection of f on the interval -3 to 3? Well, points of inflection will occur when the second derivative changes sign, which in this case is only at x equals 1. It doesn't happen at x equals -1, even though the second derivative fails to exist there, but it goes from positive to positive on the second derivative and only changes sign from positive to negative at x equals 1. So that would be our only point of inflection in this case.